Hi, in this video I'm going to discuss Many-Facet Rasch measurement or Multi-faceted Rasch measurement. It's a model which was developed in 1989 by Dr. Mike Lineker and it has become quite popular in language assessment, educational measurement, and actually other fields including medicine, some medical fields. So if you have not downloaded the software, please go to this website. I'll make sure to provide this link to the website in the comments section. Download the limited version of FACETS. It's limited to 2,000 data points or responses, and actually it's going to be very useful if your assessments, for example, are not too large and you're using it for validating in-class assessment. I think this is just pretty good enough for you, and it's actually free. Now I've already created some files here. Let me just show you what's going on. I have 3 files, input files for facets. This is the actual facet with no limitation, the one in the corner. So I'm going to show you what you need to include. Let me just close these because I had opened them before. I need to close them and open again. Okay. Yeah, so the first file I want to show you is this one, and I'm going to quickly walk you through these lines just to let you know what we need. These are actually some of the basic specifications in the input file that we need to include in order for the facets to know what we want them to do. So the first line is the title. Title equals something. I mean, whatever title that you have, and it doesn't have any, from what I know, any word limit. Of course, you don't want to write a long paragraph there. Of course, maybe just a few words just to indicate what you want to measure or what this measurement is all about. Then the other line is the number of facets. Basically, facet is any variable that affects in this context, it affects the performance or the measured performance of the students. Now, it doesn't have to be students. It could be anything else. As long as you're measuring some sort of performance, then you can imagine that there will be a number of facets that would affect that measurement. In this context, one of the important influences on the measured performance of students is the effect of raters, and we want to figure out how that might affect the performance of students and also control for it. So therefore we have got 3 facets, and if you want to know really what those 3 facets are, here I have already written them down. They include student, rater, and item. So we want to provide the information on these 3 facets to the software and ask the software to give us the location of the students on the latent variable, which is on the latent variable. On the latent variable. So then we will also find out the impact of raters and item difficulty on the estimation of the ability of students. Let me go back to the previous window here. So that's what those 3 facets are. Actually, you can put the number of facets here, and you can actually spell out what those 3 are. What I would like to do is just copy and paste from this window onto this window. So students, raters, and items are those 3 facets. Now there is one more thing to take into consideration when you're writing the input file, and that's wherever you put a semicolon, anything to the right side of that semicolon is not read by facets. So I think it makes everything convenient for you because you can put down really anything you like to, any sort of notes that you would like to remember. Now the other row here is Interrater equals 2. It could be equal to 1, 2, or 3, and I'll tell you what this means. So you want to estimate the Interrater Agreement. In another video, I have discussed how to estimate Interrater Agreement. I have also discussed Cohen's Kappa, but I'm not going to talk about that in this video. I think that video is useful. I also try to leave the link here in the comments section, so if you're interested to watch that video and compare it with facets, you can just go ahead. When we say Interrater equals 2, what we are telling here is that facets should remember that the second facet, which is rater, is what we need facets, the software, to estimate the Interrater Agreement for. So if we wanted, for example, to estimate the Interrater Agreement for the first facet, we would have put down 1. But if you don't want this Interrater Agreement analysis to be conducted, we just can change this to 0. That means facets is not going to bother doing this analysis for you, or just totally remove that line. But I'm going to keep it to 2 so we can take a look at Interrater Agreement as well. Now, the other line here is positive equals 1, which means that the first facet, that student, has a positive ability, that has a positive direction, meaning that the higher it is, the higher the scores, the higher the measure. But for rater, basically, the higher the scores, the lower the severity, because if a rater has a high mean score, that means that this person on average was lenient compared with the rest of the raters. And for items, we can actually say the same thing. Now, the other line here is non-centered equals 1. It means measure from the center of the measures for each facet. What does that mean? Let me just explain this by providing 1 or 2 examples. Let's say we want to measure the altitude. For example, the height of a mountain, or just the altitude. The anchor point that we use in order to measure the altitude is the sea level, right? So we start measuring from the sea level. And if you want to measure something else, for example, the width of your table, you start from one corner or one side of that. So the anchor point becomes the one side of your table. Basically, what we are saying here is that the anchor point should be the center of measurement, which is 0, as I will show you later for the analysis. Now, the other important part is models. So we need to specify what kind of models we need to use in facets analysis. Actually, there's a little bit of detail here which I need to go through. I'm going to spend some time here. Okay, so every question mark here represents one facet. So since we have got 3 facets, we definitely need to have 3 question marks at least. This is a very basic model. Then I'm going to actually change this model to different types of models, so you'll see that it's possible to have all sort of specification and run all sort of analysis with facets. So I think this is one of the most important things in facets analysis which we need to take into consideration. Now, what I'm saying here is include facet 1, facet 2, and facet 3, and consider a rating scale which has got 5 categories. So I have 20 items, as you see here at the bottom. I will go through that later, but just want to show you that I have 20 items. And these 20 items are using a 5 scoring category scale. That's from the low of 1, or maybe 0. I don't remember if we have used 0 here. Let's say maybe from the minimum of 1 to the maximum of 5. Therefore, we have 5 categories. Now, if you put 4, facets is going to ignore anything which is above 4. So that's going to be a source of unreliability, which will affect the estimation of all 3 facets which you have already specified. That's one thing. Now let's think about other scenarios and see how we can change this specification in different ways. Now, if you have watched my previous videos, and I'll also try to uh, leave links for you if you are interested to watch them. And I highly recommend that you watch them because they actually give you a basic idea about Rasch measurement and how to interpret the outputs of WinSteps, which is another software developed by Dr. Lineker. Anyway, so if you have watched them, you'll remember that there are two types of models when it comes to scales, polytomous scales. One of them is partial credit and the other one is rating scale model. Now, by default, this kind of model specification is actually a rating scale model. Now, we can change this to a partial credit model by replacing these question marks with a, let me just copy and paste it here, with a hash mark. So I can replace the third one, which is item, and make it a partial credit model for items. So every item will be specified, will be allocated a separate scale. That makes a kind of big difference in some cases. Or you can actually specify the second one to be a partial credit model, which is a rater. So every rater is going to have a separate scale than the rest of the raters. So I can put the hash mark here. It doesn't really matter. It depends on what I want to do. So that's one way of doing this. Now the other thing is, let's say I have 20 items and I assume, or I have strong evidence that item 1 to 10 use a separate scale. For example, it's from 1 to 5, so I just leave it as is, and items 11 to 20 use another scale, and for example it's R7. So I have two separate scales. I want FACET to know that I have two separate scales. So that's how I can specify my model. So I have to put in two lines here, and this can go on. I'm just gonna delete this part and here put in the default model that I wanted to estimate. There are other things that you can do. For example, if you remember differential item functioning, and if you have watched the video, I discussed differential item functioning within the context of bias analysis and interaction analysis. Actually, we can do the same thing here. So if you want to, for example, investigate the interaction of any of these three facets, like two at a time, then you can include a B, meaning bias. For example, bias or the interaction between facet 2 and facet 3. That's, in other words, we're asking facets to estimate the interaction between the elements of rater and elements of item. An element is actually the number of components under each of these facets. For example, for items, we have got 20 items, right? So we have 20 elements. For raters, we've got 2 raters, so we've got only 2 elements here. So yeah, bias will be, or interaction analysis will be carried out for all of those elements. The other thing you could do is, and this is not very unpopular, actually you can copy and paste. So you can ask facets to run the analysis once and then run a bias analysis, and then that will be it. The other thing you could do is, for example, I just want to put this down here. You can make one of the facets dummy. And of course, in this analysis, I'm not really interested to do that because I do have a strong theoretical framework here that predicts that item difficulty and rater severity can affect students. So I'm not going to include any dummy variables, but you could do that, and especially in this part, you can actually ask FACET to, in this part of the specification, you can ask FACET to specify one of the facets as dummy. Now, the other thing is, for example, you can ask FACET to just give you the severity level, the ability level of students from number 1 to, for example, 22. Because as you see under this specification line, we've got 74 students. So I can ask FACETS to give me only 1 to 22. That's another thing that I could do. So I'm going to delete these two lines again, and I just leave it as default. So you can, as you see, FACETS is quite flexible and it can give you a lot more options, and I think it will fall outside of the scope of this introductory video, but I think it just gives you enough idea to run a decent analysis. Now after this line, you'll have to put that asterisk. That's very important. If you forget this, FACETS will not run, and that's therefore it is quite, you know, an important part of it. Then you've got labels equals, again an asterisk, then you go through the rest of the specifications and you put down the number of facets followed by a comma followed by the name of that facet. Actually, you can either call it students. It doesn't have to exactly be the same as what you have specified here, because FACETS, as I said, doesn't read anything to the right side of the semicolon. So students, or student if you will, then you have to provide the running order for students, for example from 1 to 74. Now if the running order, and that's here, so the first column will be students all the way down to 74. I think we have got 74, yeah. If 74 is the largest number, and if you want to include every student in the analysis, so you have to provide the smallest number hyphen the largest number. But if you forget the number that you have assigned to all the students, for example, you forget that you have got 74 and you put in 73, so FACETS doesn't read number 74, and it can affect the reliability of your analysis in different ways. Now followed by an asterisk, rater 2, facet 2, which is raters 2, comma, the name of the second facet, anything that you would like to call it. Now what you can write here is, you could either write 1 hyphen 2, that means raters from 1 to 2, or you can just provide their name. So 1 equals, for example, A being someone's name, and B being another rater's name. Now if you know the name of the rest of the raters, actually can provide them here, otherwise you can just provide the range of the raters, for example 1 to 2, 1 to 5, and whatever. It would have been much better if I had a larger number of raters, really, because I would have been able to have more observations per student and per item, and that would improve the reliability of the analysis. But I think that's everything that I have afforded in this analysis. Number 3 is items. Well, that's FACETS 3, and it's from 1 to 20. In the same way, the way that I have spelled out in raters, you could either write 1 to 20, or you could provide the names. For example, 1 equals, for example, item on content 1. Then 2 equals item on content 2, and so on and so forth. Instead of this equal sign, you could also provide a 1 comma. Actually, it doesn't make a difference there. So I go back to the default, which is 1 to 20. I think that's easier for me. There are other ways. In the second file, which you see here, I have specified in kind of clustered items based on a theoretical framework which we have used for the analysis. I will also show you that kind of specification. So now then the asterisk, then the data. Data equals, and you should arrange the data in this way. Let me just show you how you can create this format of the data in an Excel sheet. So here are my 3 facets which I have color coded. Facet 1 was students, as you remember. Facet 2 is raters, and facet 3 are my items from number 1 to 20 all the way. And then I have this column that separates facet 1 to 2. It's actually called indexing, the indexing column. So you kind of index the items which range from item 1 all the way to item 20, as I mentioned before. Now, for student 1, measured or rated by rater 1, we have the score of, let me go back to it, student 1, rater 1, the score is 3, item 2 is 3, item 3 is 4, so 3, 3, 4. And you need to arrange your items in this way, as well as the rest of the facets, and this 1 minus 20. 1 minus 1 to 20, actually. That's how we read it. 1 to 20 means, especially in this part, you're actually asking FACETS to read anything up to 20 columns after this column. So 1 to 20. This A is basically a trick to prevent Excel from changing the range into a date. For example, if I don't write, if I don't include A, 1 to 20, and go to the second column, you see it automatically changes into a date. So that's a trick that you can use in order to prevent Excel to change your data to a date. Okay, so if you are interested to see how large this data set is, that's how large it is. It's column 1 all the way to column 20, and if you scroll down, you see it's the end of it. At the end, you don't have to really put down anything, and because FACETS will just understand that that's the end of it when it doesn't see anything. So I'm gonna close this, and I'm gonna run the analysis. I'm gonna save. Let me see. Yes, I hope I haven't changed anything wrongly. So yes, I'm gonna save this. So I'm gonna run the analysis. The easiest way is really to drag and drop. Here is FACETS 1. That's the input file. I'm gonna drag and drop it into the FACETS software and just wait for a pop-up window, and that's it. It's asking me if I need to make any specifications. I really don't want to make any specifications, so I just click OK, and there you are. I can change the file name, but I always actually keep it to this default because it's very easy to associate it with the input file. It just has a dot out kind of extra word there, so it shows me that this output is related to facets number 1. So open, and the analysis, this is the result of the iteration process, and there we go. This is the output, the first output that I get. So it gives you all the information that you have included, and even more, for example, the number of facets and all that. And this is the iteration. But then I think what is important, the first observation for you will be this right map, or item person map, if you will. So the first facet here is students, then raters, then items. And you have only one scale, like I said, because we're using a rating scale model. So the most difficult items are item 2, item 12, and 7. They're probably of the same difficulty level. And item 14, I say probably, even though they are falling on the same line, they might not be exactly, they may not exactly have the same score, so we can actually look at it later. This is a rating scale model. Now, I'm going to minimize this and go back to the input file and change it to a partial credit model just to show you the differences between a rating scale model and partial credit model in facets. Like I said, I can change that to a hash mark and save, close, and just drag and drop. No further specifications. I'm going to call this 1 hash. So I hope it will, yes, okay, it will accept it. Now let's wait for a second here to see, yeah, the results are out. You're going to see a much larger item person map because now we have 20 items, yeah, you see? So we have one specific scale for every item. This is for item 1, item 2, all the way to item 20. On the other hand, we only have one scale for all the items, and that's the difference between the partial credit model and the rating scale model. Yeah. So what I'm going to do is to close this really and quickly walk you through this. Like I said, students is the first facet, raters is the second one, and items is the third one. And here is our the first column here, the measure, is our latent variable. So what we are doing is that we are asking facets to consider the scale of items, also consider raters and students, to estimate the location of students along this line, along this latent variable line. And that's what FACETS has already done for us. Now, well, these are, very useful information, but it's actually the same as, almost the same as, for example, what let's look at this one. It's the same as what you have here. The first one, the first block of information, which is from logits to outfit standardized, Z standardized, relates to the first facet, student facet. Now, that's the first facet for us. Now, the second one, naturally, pertains to raters. And let me just find it, raters facet. So this block of information and visualization has to do with, here actually, up to here, has to do with raters and then items. Okay, so what we can see here, let me just go through students, that's which is the first facet, is this is the mean of students in logis. So the mean of students is -1. There are 7 people around the mean of the population, or the sample, if you will, not really the population, the sample. There are 5 people here. There are 2 people on this location. Now, in the same way, we can go through the quality control statistics, which are infit mean square values, outfit mean square, as well as their Z standardized versions, which is infit and outfit Z standardized. I have discussed this in a lot of detail in other videos, so I'm not going to discuss it too much here, just for your information. Infit is an inlier sensitive kind of statistic which captures the anomalies and erratic patterns in the data which are closer to the ability level of students. On the other hand, outfit captures the anomalies or erratic data on extreme points of the scale. So in facets analysis, well, basically there is a range in which you can say that the measurement has been useful and is accurate. So another way of looking at infit and outfit is that they are statistics of accuracy. So if they fall between 0.5 and 1.5, you can say that the analysis has been accurate and you can actually rely on the output. For Z standardized, it's usually between -1.96 to plus 1.96, and if anything falls outside of that range, well, the accuracy starts to be less reliable. And like I said, please watch the other video. I'll make sure to leave the link here for you in the comments section, so you can go through the video and refresh your memories of what those statistics are. So I go down here, and there are a lot of tables here, including observed average, total count, and fair average. Now, I'd like to explain what this fair average is. Like I said, the most important facet in this analysis for us is students. So the highest ability here is student number 56. and actually 52 as well, because the total score of these students is 40. That's the total count. The total score is 143, followed by 52, whose total score is 127, and so on and so forth. The observed average is that if you divide this number by 40, you'll get around 3.58. Now, this score is still affected by the other two facets. That's the severity of raters as well as the difficulty of items. Now, if you take away the severity of raters and item difficulty from it, you'll get 3.56. That score is called fair. It's fair in the sense that it's not affected by the other two facets in the analysis. So this is something more reliable than this one in most cases. And actually, I have discussed the rest of these in another video. I'm not gonna spend too much time here. You see, you get in-fit and out-fit mean square values in z-standards for every student. The other thing you would want to look at is the reliability analysis, and you want this to be above 0.8 because you really want your measurement to differentiate between high ability and low ability students. Here we've got 0.9 of reliability and a separation value of 3.03, which means that there are around 3 separate levels of ability, which is pretty good news for us because it indicates that our measurement has been able to identify 3 different levels. So there is a good this is a good indication of the discrimination power of the measurement. Now this is again students measured, and this time round they are arranged by fit, I think. And if I'm not wrong, it's probably fit, but they've been arranged in a different way. Yes, if you see, if you look at here, the fit of this person is the highest. So I would probably go through these performances, these 6 performances, and see what's wrong with these 4, and would try to see if I can correct any problems that's observable. And here is by the identification number of students. And the rest of this is actually okay. This is for raters. Let me drag this from the side. This is for the raters, and as you see, the raters, the first thing that I usually look at is their fit. Yeah, they have a very good fit, so the performances have been fine. I can rely on these raters. And the other thing here is, interestingly, they are significantly different in terms of their severity level. So it matters really which one of these 2 raters scores the student performance, because as you see, one of them has a measure of 0.11 and the other one is minus 0.11. So this is a potential source of what they call construct irrelevant variance, which we need to take away from the actual score of students. And I've already mentioned that when we take it away, we actually get closer to what they call a fair average measure. So that's the reason why we need to partial out or control for the severity level of the raters. And finally, the items also have a range. They are kind of very different from each other. There are at least 5 levels of separation here, which is pretty good because we want our items to be different from each other in terms of their difficulty level. So a reliability of 0.97 is high and quite promising for this analysis. I'm going to close this. I'm going to close this as well. Just one quick analysis of FACETS 2. I don't want to drag on this video really because I know that this will be quite exhausting for you to watch a long video. This is what I have done as well. This is just to show you that you can specify how the items cluster with each other. So item 1, 2, and 3 actually measure introduction. So you can write 1 hyphen 3 equals intro, comma, comma 1. So that means they go together. This is the first kind of subscale. This is the second one. This is the third one. This is the fourth one, and fifth one. So the rest of the specification is exactly the same. I'm going to close this. I'm going to throw it into FACETS just to show you how it changes the visual specification. Let me click open and run the analysis. As you can see, the iteration is going on. There are many iterations, and the reason is that we have quite a little bit of missing data there, because not every rater has scored all students. But as you see, the subset connection is okay. This is good news, which means that the scale is not disconnected. If there is, then we have to really think about that and see how you can resolve that disconnection. So previously I had assigned numbers here for every item, but now I have their assigned subscales. For example, body, conclusion, and so on and so forth. But if you go all the way down to items, you can also figure out, their assigned number. So assigned number 1 for introduction, number 2 for introduction, number 3 for introduction, and so on and so forth. Okay, so I think this was just a very brief overview of facets. I haven't gone through a lot of other things, but I think it's perhaps useful if you want to run a quick analysis in facets analysis in the FACETS program. I will leave this part in the comments section as well, because you can actually use it and reconfigure it for your own analysis. In other videos in the future, I'll try to include more facets in the analysis. I'll try to include, for example, dummy variables, anchored variables, just to show you how other forms of analysis can be conducted. Just one last thing is, if you're interested to find out how the results of FACETS analysis and interaction analysis, for example, in FACETS are presented in published papers, here are two, which I also leave in the comments section. In this paper, we investigated the effect of gender and academic major bias in peer assessments of oral presentations, and in the other one, we used FACETS also in the validation of oral presentation scores of students. Okay, thank you very much. This brings me to the end of this video. I hope you enjoyed it, and I hope you find it useful. If you did, please give it a like and subscribe to the channel, and have a great day. Goodbye.